Hello everybody, welcome to another video lesson. Today we're going to start our lessons on rational expressions. Today we're going to be multiplying and dividing rational expressions, and we're just going to simplify some expressions and complex fractions. That's our objective for today, so let's hop right into it. All right, the definition of our rational expressions here is just a ratio of two polynomial expressions. Okay, ratio of two polynomial expressions, that's all it takes to be a rational expression. Now, we can go ahead and when we simplify this, we're going to go ahead and divide by the greatest common factor. All right, which you guys have done before, right? So a little recap, if I've got 10 over 15, in order to simplify that, you guys do this in your head. You're going to say 10, factor that out is 5 times 2. 15 factored out is 15 times 3. Our 5's cancel, and we're left with 2 over 3. Now, similarly, if I've got these polynomial terms here, I've got x squared minus 4. I've got x squared plus 5y, y squared minus 4, y squared plus 5y plus 6. We can factor out both the numerator and the denominator. Okay, so I've got factored forms here, and I've got the same y plus 2 on the top as I have on the bottom. All right, so that would go ahead and cancel out, and I'm left with y minus 2 and y plus 3. All right, so let's look at how we multiply and divide our rational expressions. In order to multiply and divide, to multiply, we just multiply our numerators together and we multiply our denominators together. Just multiply across, similar to how you would do with any multiplication of fractions. And our division doesn't change either. We're just going to multiply by the reciprocal of the divisor. So if I have our 10 over 15 and multiply that by 3 over 4, we would just go ahead and multiply across. So I've got 10 times 3 over 15 times 4, and we can factor out our 10 and our 15, as well as, let's see, we're going to factor out this 4 into 2 and 2, and we've got a bunch that cancels out, and that simplifies to 1/2. Similarly, if I've got 10 over 15 divided by 3 over 4, we're going to think of that as 10 over 15 times 4 over 3. Okay, the reciprocal of our divisor here is going to be 4 over 3 instead of 3 over 4. We're just taking our divisor and flipping it. That's our reciprocal. Okay, so now we can go ahead and factor everything out. So we got 5 times 2 times 2 times 2, and 5 times 3 times 3. So our 5's cancel out. We're left with 8 over 9. All right. So let's go ahead and take a look at this in a more generic term. So if I've got a over b times c over d, okay, we just multiply across. It's going to be a times c over b times d, which in this case we would just simplify to ac over bd. Okay, and then if I've got a over b divided by c over d, we're going to multiply by the reciprocal of our divisor. So it's going to be a over b times d over c, and that'll simplify to ad over bc. Now, if you see something like this is called a complex fraction. Okay, do not freak out. All this is another way to represent what we have over here in the bottom left. Okay, this is the same thing as a over b divided by c over d. It's just represented in a different way in this complex fraction. So don't let that get you confused. Okay, all we're going to do again is multiply by the reciprocal of our divisor. In this case, it would be our whole denominator. So this would just be a over b times d over c again, which we just did over here. Okay, let's go ahead and hop into some examples. All right, if I've got these polynomials in my numerator and denominator, first thing we're going to do is factor everything that we can. Factor, factor, factor. So I will factor out my numerator. My numerator is already factored, so I can't do anything there. But I can factor out my denominator here, right? I can factor out this y squared minus y minus 6. Okay, that's going to factor into y minus 3 times y plus 2. All right, now we can just see what do I have in common on the top and bottom. Well, I've got the factors of y, and I've got y minus 3. So I'm going to go ahead and cancel those out. Those cancel to 1. Just keep that in mind. Those cancel to 1. Now, be careful here. A common mistake that students will make, they'll see this 2, and they will try to simplify with these 4's here. Now, because 2 is in this factor here of y plus 2, and it has separation by addition, I cannot use this to simplify these 4's or anything else, all right? If there is a y plus 2 factored in the top, then I can cancel the whole term out. But right now, I cannot cancel this y plus 2 with anything else in my numerator because of this separation by addition. All right, so keep that in mind. So what we're going to have here will be 4y plus 4 over y plus 2. Now, keep in mind, if you're asked to describe any domain restrictions, you have to go all the way back to our original statement here, our original expression. I can't just look at this y plus 2 in my denominator. Now, with my rational expressions, what limits our domain are the values of our variable that create 0 in our denominator, right? So our denominator cannot equal 0, so we're going to go ahead and set the denominator not equal to 0, and we're going to set each term in our denominator not equal to 0, and when we solve here, we find that y cannot equal 3, y cannot equal 0, and y cannot equal negative 2. So if we're asked to state any domain restrictions and simplify our expression, this would be our final answer. Okay, so use that exact same process and see what you can find here on the right-hand expression. All right, so hopefully you got something that looks like this here with domain restrictions of -5, 1, and 2. Okay, we're going to go ahead and simplify a couple more, except with a little twist here now. Okay, so we're going to do the same process here. I'm going to simplify the top as well as the bottom, or I'm going to factor the numerator as well as the denominator. So I can factor out a z here, and I can go ahead and split this z squared. That's just z times z. I'm going to represent that like so you can see how they cancel out. Now we see here I've got x minus 4 in my numerator, and I've got 4 minus x in my denominator. So now what we can do, since this is the difference, okay, these are both the difference of these two terms, right? X minus 4, 4 minus x. What happens if we factor a -1 out of either of these terms? Well, if I factor a -1 out, what happens is our signs flip, okay? Which we're allowed to do because if I factor, or if I distribute this -1 back, then our signs just go back to what they were. So if I factor out this -1, now my signs change, and we have a 4 minus x in the top and bottom, which we can cancel out, and our final simplification is going to be -1 over z. Okay, so go ahead, use that exact same approach and see if you can't find the simplified form of the expression on the right. Alrighty, here we go. I have -ab all over 5 plus b. Keep in mind, or just notice that I factored the -1 out of the denominator this time. It does not matter which one you do, just pick one. However, if you factor the -1 out of the denominator, remember that proper notation is to write our negative sign either in the numerator or out in front of my division sign, okay? I am not going to keep a negative sign in my denominator. That is not considered proper notation, okay? So negatives out in front or on the top only. All right, now we're going to get into some multiplication here. Okay, so I've got 12d squared over 21b times 14b over 8c squared. So again, we're just going to multiply across the top and multiply across the bottom. It's going to look something like this. Now I can just factor out everything in the top and everything in the bottom separately. All right, now you guys can probably see how to simplify from here, right, from this expression here. But however, I'm just kind of showing the long version of what you're doing in your head, right? So I've got 3's on the top and bottom. I've got a bunch of 2's that cancel out in the top and bottom. I've got a 7 in the top and bottom that cancel, and our b's will cancel as well. And we're left with d squared over c squared. That's all that's left over in this expression. Okay, we got our d's here and our c's here. Okay. So we'll go ahead and do a similar process here on the right-hand side. We're going to go ahead and factor out this top left numerator. Okay, so first thing I'm going to factor out a 4, and then I'll use my cross method here to find the factors of this 2x squared minus x minus 10. That's going to be 2x minus 5 and x plus 2. And we can go ahead and then we'll factor this top right numerator. That's going to be x minus 5 and x minus 2. And then the bottom left numerator, factors to x plus 7 and x minus 5. And then if we factor out a 4 here, we're left with 4 times x squared minus 4. That is a difference of squares, which factors into x plus 2, x minus 2. Hopefully you guys remember those. And we can go ahead and cancel out what cancels, and we're left with 2x minus 5 over x plus 7. Okay, now we're going to divide rational expressions here. Again, very similar process. We're just going to multiply by the reciprocal of our divisor. Multiplying by the reciprocal of our divisor gives us this. We can cancel out our 2's. We can cancel out our 7's. Our m's and our a's cancel out, and we're left with just 2 over 9 with this example. Okay, so go ahead and pause again, and you guys see if you can simplify this division here on the right. Okay, hopefully you got 6 parentheses x minus 5 all over x plus 3. That would be, this is the correct simplification of this division. Now we're going to go ahead and simplify our complex fractions. Again, do not get freaked out when you see these. Just think of them as the notation that we saw earlier. Okay, and when we know this notation, we know that we're just multiplying by the reciprocal of our divisor. Okay, so I'm just taking my divisor and I am flipping it like so. All right, so I've got our multiplication set up here. We just multiply across the top and the bottom. So the top is going to, again, this is difference of squares up here. So that's going to be x plus y and x minus y, and then we'll have y plus 7 as well. Okay, and then we'll have difference of squares in this denominator as well. So we got y minus 7 times y plus 7, and we've got y minus x also here. Okay, so all that cancels is y plus 7. However, notice we've got a difference here of x minus y. But we also have y minus x. So when we have this set up, we can factor out our -1, and that's going to give us a y minus x on the top. That'll cancel out with the y minus x on the bottom. Now I have this -1 y, or x plus y, all divided by y minus 7. That is our final simplified complex fraction. All right, guys, that is all we have for this video. Good luck with your practice.